everyone. This is Ty Warner with KissSoft Tech Support and Taika Engineering. We should probably talk about plastic gears since they are very, very common and probably, we're seeing even more and more plastic gear use as we kind of move forward. One of the things that's really important about plastic gears is temperature. Also, their matrices are a lot different than steel or aluminum or tungsten or whatever material you think you're going to use. They are very much anisotropic, and they are very much affected by temperature. Okay, so one of the things we got to talk about is how we actually analyze these in KissSoft. The first thing we need to talk about is the standards that we're using to calculate the gears. And in 2013, VDI 2736 came out. And basically what we require is static strength calculation, which is a yield and ultimate strength, and tensile and yield. Wear calculation. If there's a wear factor, material combination, lubrication, we can do an iterative wear calc. And then lifetime calculation using SN curves for root and flank. And these are as a function of temperature. Here you see the SN curves, or Wöhler lines in German. They depend on the actual root flank temperatures. They are required as a function of temperature, and you can see when we measure these, it's very time consuming and expensive. You can see we've got gears at different temperatures, right, for the root and the flank. So this is really important if you're going to do plastic gear design, if you're going to do an in-depth analysis at least. And here's what KissSoft does. So we have these .dat files in our installation directory, and there's ways that you can actually modify these for your own material properties. Okay, so for yield strength and ultimate strength, you can look at this. Here's the data. This data 0, 1, E. This is your number of cycles. All right, on this first column. The second column, it has on the top of the column it says 20, the third it says 40, 60, 80, 100, and 120. Those are the temperatures in Celsius for this material. The corresponding data underneath the top of those columns then is the tooth root strength, okay, in Newton millimeters squared. So here's the tooth root strength at temperature and at our cycle count. So this is our Wöhler line or SN curve for this material. And these are located in your installation directory and program files. So I'm talking about KissSoft 2022. KissSoft 2022 is located in your C program files, and it's going to be right here in your KissSoft AG folder. And then you've got 2022 and 2021. In 2022, we have this DAT folder. If we look at this is all of our material and some other tables in here, right? So if we scroll down, we can look at all these different things. And here we have some of your VDI materials here. There's other materials in here as well, but if I double click on one of these, let's say I look at nylon 4.6, if I double click and open this, I get this file is equal to this. So this is my file name, all right? This is my the data for PA46, it's a tensile taken from Stenil 341. Okay, so this is Stenil, it's a DuPont material, and they gave us this information. And you can see in here now, coefficient of friction for oil, grease, and dry running. All right, and then we have the modulus at -50, 0, 20, all the way up to 200 degrees Celsius. And then we have ultimate tensile strength at different temperatures, elastic strength at different temperatures, and then we get into our tensile fatigue. Okay, this would be a tensile fatigue on this material. All right, so you've got this is our table. This 23. These are our temperatures, and this first column is our number of cycles. So just like an SN curve, only it's at different temperatures. So we have this other information about limiting values for material data. We have minimum temperature, maximum temperature, and that kind of stuff. All right. We don't have the root and we don't have the flank information for this particular database, but that doesn't mean we can't add it. So when we do our own, we might take this out and save it as something that's been modded. And when we do that, let me just put this down. We're going to save those files in this ext folder under DAT. Okay? ext DAT. Oh, I'm missing a whole bunch of information here. I'm not sure. Let's go to 2021. And here's a whole bunch of files right here. Okay? That's for 2021. All right, I opened up Kissoft 2022, and because I don't have that stuff, I'm gonna update my database, and I needed to update this external. This is my ext, so I'm gonna go and run. I'm gonna highlight program files, Kissoft 2021. I want that whole thing updated. I'm gonna select that, and then it updates it. Okay, updates all that stuff. Good stuff right there. Real easy to do. Just run it. You're done. There's a video on how to do this. Okay, now I'm going to close this. If I go back into my Kissoft 2022 now, everything is in there. All right. Now that was a TW 371 data. So here you see I have two different data sets in here in my 2022 version. If I click on the first one, you can see that this is from DuPont. Okay, and these are files you can get. You can download these files. You can see we have ultimate strength, elasticity, modulus, yield strength, and so forth. Another file, if I were to look at back here in my data file, if I look at, for instance, this VDI 2736 PA66 right here, if I double click and open that, and I scroll down, you'll see I've got tooth flank and I have tooth flank strength, and I've got tooth root flank. Tooth root strength right here, right? And it could be that I'm really interested in this data, and I want this data in my new folder. But I have, so you can see here there's a 2736, and then there's a 2545, and they're a little bit different. So if you're using 2736, what you would do is you'd copy this out of here, like so, and then you'd plug it into this other database. Right down underneath here, right? Boom, there you go. Now I have a tooth root strength, and I might have to go through and change these values right here to what they need to be at these cycle counts. That information at temperature might take you a little bit of effort, but when we do that, we get this modded. So I have a modded data file here. Oops, I don't want that one. Yeah, I did want that. So if I look at this 371, I have this modified data here. And you can see that's exactly what I did. I just went and copied this information out of that other right here, because it's got all the format that I need, right? And then I pasted in here like I just showed you. And I can now manipulate all this information. I can put the values in here that I want. I can change this over to a PA, 4.6, whatever I need to do, I can do that. Should be square anyways. So I can change these. I can change this to a 4.6, right? I can put the right name on here that I want, and then I just adjust these values to whatever I want. And right now, for this one, I added the tooth root strength for 80 and 140 degrees. So I've got this information right here, and I already have the tooth flank strength up here, and I brought that in from another one. A lot of times you'll have to talk to your suppliers, and when you talk to those guys that have the actual material, they can provide you with different curves and strength curves for at these different cycle counts. So it's basically an SN curve at temperature, and then you basically create this table. You have your cycle counts, and you have your temperature. You'll then need to verify that this information is exactly what you want. It's the right information, and you can publish all this. And when you're done with this, you're going to save it. I'm not going to save that. But when you save it, you're going to save it in the EXT database as whatever this is. This happens to be a modified TW371 material. Okay, and you can see I've got a 271 that I've extended some stuff on, and I've got these other materials in here that I've probably gone in and made some adjustments. Okay, and that's all from information that I get from the material supplier, if they have it. So a lot of times we ask for that information. What this means for you then is when you create a data file for some kind of a material, you're going to log in as the administrator, and then you're going to go to, let's see, where am I going? Right here, database tool. It's going to give you this open with right authorization. And now when I go in here to basic data, all that material that I had in here is going to be in here. You can see I've got all this new stuff above 20,000. And if I highlight on one of these, like this POM 111P, I double click that, I'm going to get this basic data card that comes up, and you can plug in all this information. And I say okay. And then if I wanted to see then, oops, cancel this, close it. No. And if I want to see the gear information now for that material, I'm going to go down and I'm going to find this POM 111P. And when I open it up, you see this file right here? I can just click and go grab it now out of my EXT. Because it's going to be one of these right here. ext.dat, and it brings me here, and I can grab one of these. Anything that I grab on here, if I grab it, it updates this. I'm going to put my endurance and my for my root and my flank on here, and then I'm going to say OK. And when I say OK, and I save this, now when I look in here for this POM material, wherever that might be, it's one of those. This one right here, I think. It's a 111. If you hit the plus button, you can see a little bit better from charts right there. And then I can select it, and that'll have it. And if I'm just curious about that, if I highlight this and go up to own input, I can see in the calculation data that that's the file that is pointing to. I must have grabbed a different POM. Oh, right here is the one I was looking at. Again, but if I go to my own input, then I can see that under the calculation data, I can see where the polymer data is coming from in temperature. Okay. So that's how you would modify that. Just grab the table that you need from another data file, copy and paste it into the one you want, save that as a new name in the ext.dat file directory, which is this one right here. So you're going to go into ext.dat, save it as some new name, and then make your changes, and then you can save it in there. And then when you set your material up in here, you're just going to point to that folder in that DAT file, and you'll be able to use that new data in your calculation. Incidentally, your strength file, you're going to run this VDI either method B or method C. I think one of them is like a graphical method, and there's a little bit difference between how it calculates the Lewis form factor, I think, between the two. I normally use this method C. but either one will work, and then you can run your calculation just like normal. Okay, so that's how we would look at adding an SN curve to the plastic database if we want to do a good analysis on the plastic gears. Feel free to subscribe, comment below if you have questions. Hopefully this is clear. If not, just let me know, and maybe I can make it more clear. But thanks for watching, and we'll talk to you again next time. Bye.